burning of fossil fuels. When you burn coal, there's a certain amount of sulfur in coal, there's a certain amount of nitrogen in coal, and of course there's a certain amount of carbon that combines with the oxygen to form carbon dioxide. All these things end up in the atmosphere unless they're recycled in some way. And of course, when the Industrial Revolution hit back in the late part of the 1800s, we were cranking out stuff into the atmosphere like you wouldn't believe. And the old school of thought was dilution is the solution to pollution. In other words, the earth is so big, the atmosphere is so large, the oceans are so vast, that it doesn't matter what we put in them, it'll clean itself. This works up to a certain point. Once you get to a certain point, it can't clean itself anymore. But what happens when you combine oxygen with these nitrogen, sulfur products is they form sulfates and nitrates and nitrites, which combine them with water in the atmosphere to form sulfuric acid, nitric acid, those types. So we have this acid precipitation, and it falls wherever it falls. It falls on large bodies of water to increase the acidity of that body of water. A certain change in acidity will kill certain types of living organisms off. So, forgetting things like global climate change, one thing we're doing when we pollute is to actually change the nature of the environment to the extent some organisms can't adapt. And again, you use natural selection. Some of them will make it, as a rule. But there have been cases where whole populations and whole species have been eradicated just by a shift in something, acidity, temperature, whatever. And this acid rain has a bad effect on plants. We saw, I think, Tuesday, some pictures of a forest that had been exposed to quite a bit of acid rain. It sulfuric acid in particular dissolves parts of cement and parts of rock, and so it puts marks and statues and compromises the integrity of bridges and all kinds of stuff. So anyway, that's acid deposition or acid rain. Well, dealing with global climate change, I'm going to add something to this. It may be that humans just have to learn to live with it. But the little things that we do try to do is to increase efficiency of automobiles, invent alternative fuels, and this is an ongoing thing. There are new types of technologies that can pull carbon dioxide, the carbon out of the smoke, or I like to think of it as the egestion from a factory process, and recycles that carbon into something maybe even usable, but at the very best, or least, it makes it not dangerous. It reduces the amount of CO2 that goes to the atmosphere. Trees are the #1 storer of carbon in nature. The big forest, particularly up in the northwest, those big pine forests, are able to store unbelievable amounts of carbon. In the form, they take the carbon dioxide and remove the carbon from it and store that as carbohydrates or something of that nature. As we destroy the forest, then we destroy the Earth's ability to reduce that atmospheric carbon. It causes all kinds of changes. So when we talk about gas-saving cars and alternative fuels and letting KU put that thing on your air conditioner, it saves you $5 a month. And it really happens. And we never notice it, working. It turns the air conditioner off for a period of time in the middle of a cycle, and you don't notice it. I noticed when the $5 a month started coming back on my bill this month. But we're on the budget, so it went from one amount to another. We don't use a lot of electricity. Our our budget's $84 in the summer and $89 in the winter. We have a 3,200 square foot house, so we've done a whole lot of things to it. We've spent a lot of money putting in all the energy efficient windows and ultra insulation and stuff. It makes you more comfortable. All right. Now the atmosphere itself is where we live. You might not think about it. We're not underground livers for the most part. We don't live up in space, so we spend the majority of our life in the atmosphere to a certain extent. Our feet are on the terra firma, the lithosphere, and so we're moving around primarily in the atmosphere. Sometimes we get into which other sphere? If we're standing on the lithosphere, we live mostly in the atmosphere, which we occasionally get into the hydrosphere, into water. But it's not our natural environment very much. We can't live long periods of our lives in water. We have to come out for all kinds of reasons. But this is where we live. This is where weather occurs. Some planets don't have weather. Why? They don't have atmospheres. Some planets have atmospheres that are so dense and full of gunk that no living thing could actually survive. No living thing that we know about, anyway. And also, as a result of being where weather occurs, then it is also where climate occurs. So it's the atmosphere that impacts what's going on in or around the Earth, on top of it, and so forth. So respect your atmosphere. Every time you take a breath, be thankful for it. My worst nightmare. My nose is stuffed up at night, I have a cold. I have this recurring dream that I wake up and I'm in a casket under the ground. And I would rather somebody hit me with a flamethrower and bullets than to think about. And people, before they embalmed, hey, people got buried alive. Now, Edgar Allan Poe wrote a very terrifying story. Of course, Poe was on drugs and he had all kinds of mental problems, but he was a great author. All right, we've said this before, that basically 78% of our atmosphere is actually nitrogen. Nitrogen is a gas, N2. We cannot use it directly, so we inhale a bunch of it and we exhale it right back out. Those plants that are carbon fixers, nitrogen fixers, and it's not the plants themselves, but the microbes that live on the roots, are able to pull that nitrogen out of the atmosphere and convert it to nitrogen fertilizer. This is the way nature intended for fertilization to occur on land, but when we take the product out, then we have to artificially replace it with the stuff that we remove when we harvest the crop. So it's kind of a catch-22. Around 20 to 21, I think the amount of oxygen's actually gone down to 20% in a lot of, and it varies. It varies per season. Strangely enough, about 1% of our atmosphere is argon. Anybody know what the only major use of argon is?
Welding.
Okay, it is used in welding, that's true. For a long time, it was the gas that they put inside light bulbs. Edison kept making these light bulbs, but he left the oxygen on the inside of the globe, and they burned for about 30 seconds and burn up. He went through about 5,000 different fibers, thinking it was the fiber he was burning, the wire. And finally, they determined that if you pump the oxygen out of it, it'll last a lot longer. Put something else in there. Argon is what we call an inert gas. It's like helium. It doesn't react with anything much. How's it used in welding? I knew it was.
It's a shielding gas.
Shielding gas, because it's inert. It doesn't react. It doesn't burn. Yeah. So, interesting. I took welding in 1963. Two of us took it in summer school, Butchie Lewis and myself, between our junior and senior years, and we built the lumber shells for the shop. It was about 3 years.